Let's explore what an Anova is, what it's trying to accomplish, and how to do it. Anova stands for Analysis of Variance, and the statistic that it produces is called an F ratio. So that's what we'll refer to much of the time. When you do an ANOVA, you need two types of variables. One has separate categories. They could be ordinal or they could be nominal. You need at least three. And once you get to six, and six is kind of a high number, you need a really big sample for that. Um, Getting beyond five, it gets kind of tough. Six is possible. The other one technically is supposed to be a continuous or interval variable, where the like a count of something. Ordinal variables will work, like Likert, and in fact, much of the time in social sciences, it is a 5-point Likert scale. Like I mentioned before, the F ratio is the statistic it produces, and it is closely related to a t-test. Even there's a direct relationship. So an F score is the t score squared. But let's talk about it conceptually. The math matters. It's hard to use in ANOVA without understanding some of the math. But the concept matters more. It's impossible to use without the concept. So I'm going to use an example here with three groups. As I said before, there can be more, but it starts getting less useful after about five. An ANOVA compares the variance, the spread outedness of scores within a group or inside of a group, compared to the variance, the spread outedness between groups. If the difference within a group is small compared to those between groups, then the groups are statistically different from one another. The key idea is to compare within group variance to between group variance. So take a look. This is all of you, and I ask all of you to tell me how many states that you'd visited. And then I've grouped you. There are people from Indiana down at the bottom. There are those of you who are from adjacent states like Michigan and Illinois in the upper left, and those of you from other states in the upper right. So the residents of Indiana have visited 5, 11, 15, 10, 7, and 7 states respectively. Those from adjacent states, 15, 18, 17, 14, and 13. And those from other states that aren't Indiana or an adjacent state, 23, 27, 20, 25, and 14. So we're examining college students and we're grouping them, and the different states are grouped, but the important thing here is those people who went to college in state, do they travel less than those who traveled from an adjacent state to get here compared to those who traveled even farther? The average for the people in Indiana is 9.2. The average for those from adjacent states is 15.4, and the people from other states is 21.8. So in our sample, they are in fact different, but the question, as always, is that difference big enough to say we're confident that there's a general trend here? The total mean for everyone is 15.1. Another way to ask if someone is ask someone how many states they visited, would that give you a pretty good idea which group they belong to if you didn't already know? The ANOVA tells us that whether the groups are different from one another. It does not tell us where those differences are, just that there's some difference in there. We'll get to the post hoc tests in the next lecture. And those post hoc tests are related to t-tests. Do you remember the sum of squares? We use this in calculating the standard deviation. Now we're going to use it to calculate the sum of squares within the variance inside of a group. Step 1, calculate the mean of each group. And I have those listed down at the bottom. The mean, as I mentioned before, for those in Indiana is 9.2. Those in adjacent states, 15.4 states that they visited. And in others from other states, 21.8. And then their specific scores are listed afterwards. Step 2, subtract the mean of the group from each individual score. For example, someone from Indiana visited 11 states. We subtract the mean of the Indiana group from, we subtract 9.2 from 11. But someone from Illinois who's visited 15 states subtracts the adjacent state average, which is 15.4. Then we square each of those differences. We add them up, thus giving us a sum of the squares. And sometimes the sum of squares is symbolized by SSE. This means sum of squares for the error. But that's really it's technically correct, but it's misleading. So we're going to use SSW, sum of squares within. That means we calculated the sum of squares comparing people within their groups. Here's what the specific calculations look like for each person. I'll pause here for a moment so you can see. It's the individual score minus the mean for their particular group, and then that whole thing squared. We have everyone listed there. And the total sum of squares within is 184.84. Now we calculate the variance between the groups, the sum of squares between. In this case, we compare the mean of each group to the total mean, so the mean for all 16 people. In that first formula, you see the mean for the group, the x within the bar, that's the mean for the group. You subtract from that group mean the total mean, the x with the bar followed by a t for total. The total mean is 15.1. Because the groups are different sizes, you multiply each difference by the number of people in that group. So the Indiana group has 6 people, multiplied by 6. The other two groups have 5 people, multiplied by 5. The total of those 3 scores is the sum of squares between. So you can see Indiana average is 9.2 minus 15.1, the mean for the whole group. Square that, multiply it by 6 because there's 6 people, and you get 208.86. And then do the same for the other 2 groups. The next step is to calculate the means of the sum of squares, symbolized by MS, mean sum. To do this, we divide the number in each calculation. For the within groups, that means dividing by n, in this case, 16 people. For the between groups, we divide by k. K refers to the number of groups, in this case 3. So the within, we divide by n. 16 people divided by n, 16. The between groups, we're comparing those 3 groups to one another, we divide by k, 3 groups. But we need to make a slight adjustments to the degrees because of the degrees of freedom. Just like with some situations, the degrees of freedom is n minus 1. In this case, we subtract k from n. The number of groups is subtracted from the number of people. And we subtract 1 from the number of groups. That's how we got the calculations up at the top. But we need to make slight, oh, I'm sorry, I just said that. We divide the sum of squares between by k minus 1 to get the mean squares between the groups. We divide the sum of squares by n minus k to get the mean square within the groups. Going back to what we were doing conceptually, if the variance between the groups is comparatively large and the variance within the groups is comparatively small, we get a large F ratio, and that's likely to be significant. So here's that same formula up at the top, and then the specific scores that we got from our earlier calculations. 505.76 minus 3 minus 1, or divided by 3 minus 1, so divided by 2. And then 184.64, that's the within variance, divided by 16 minus 3, or 13. And so then the resulting mean squares, 252.88 is divided by 14.2. That's the between divided by the within. And then that gives us our F ratio, 17.81. So that's the score that we came up with. Now in this table, we need to calculate the degrees of freedom. Degrees of freedom is n minus 1. When n is 16, there are 16 of you in the class, minus 1. Now, the way to find that on this is you look on the left side where it says denominator degrees of freedom. And it's 10, 11, 12, etc., etc. The denominator degrees of freedom is 13. That's the n minus k. And the numerator degrees of freedom is k minus 1. So that's a 2. So you go over 2, and you go down to 13, and then where they meet is a 3.81. That's the threshold for significance. Now remember, the F ratio we got is 17.81, which is bigger than 3.81, and therefore it's significant. Let's do another example. In this case, we're comparing the number of jobs someone has had to their state of residence. Pause the video here, take a look at the data, spend some time calculating the Anova, unpause when you feel you've calculated as far and as well as you can. Okay, welcome back. Notice that we calculated the means for each group. Hopefully you did the same. 3.67 for Indiana, 4.40 for adjacent states, 5.80 for other states. We want to know if these groups are different, and there's their individual scores lined up with it. The total we're calculating for sum of squares within each of the individual scores compared to their respective mean scores, and then we will add them all up, and they come up to 52.02. In your calculations, if you got something really close to that but not exactly, it's just a rounding error, so you're fine. Now we're going to calculate the between group variance. The means, as I mentioned before, 3.67, 4.40, 5.80, and the total mean is 4.40. So this time we compare each of those group means to the overall mean. And then we would, again, multiply the number by how many people are in that group, 6, 5, and 5. The total we got here is 12.99. Now we calculate the mean squares. To do this, we divide the sum of squares of the between by k minus 1, and we divide the sum of squares of the within by n minus k. Then divide the mean squares between by the mean squares within. This is our F ratio of 1.62. Now let's compare it to the table. Again, the Degrees of freedom remains the same. For our denominator, the n minus k, it's still 13. And for the k minus 1 across the top, it's 2. We see where they meet, it's 3.81. And our F ratio of 1.62 is too small, so the groups are not statistically significantly different. So now I'm going to show you, I'd like you to take a picture of this or jot these down. You can pause it if you need to. I want you to find these on the table. This is SPSS output or statistical output, so that you can read the table effectively. This is a table. 3 groups are being compared. Find those statistics that I listed on the previous page. Of course, you can just rewind it if you want to find them. And I suggest you pause this while you look over the table and get familiar with it. Okay, welcome back. Let's move on to the answers, and then of course you can rewind as you see fit. Any surprises? Did you find what you're looking for? Please take notes so we can discuss these. There will be worksheets to do later that you'll be asked to interpret. Thanks very much.